If you guys can't see past me, I recommend just moving over a seat because when I'm standing and I want to stand, I kind of block this side a little bit. I would just move over a seat. Okay, you guys, when we were doing chapter 5, we did something like x squared times x to the 4th. Jackson, when we multiply same bases, what do we do to the exponents? You add them. So we will get x to the 6th. When we multiply, we are actually adding the exponents, right? There is a logarithm property because logarithms are the inverse of exponential. There's a logarithm property that is similar to that exponential property. It is called the product property. Right here, the product property says if I have a logarithm of some product, so m times n, I have a logarithm of some product, meaning multiplication, I will rewrite that as separate logarithms added together. So if I have a logarithm of a product, I can separate that to be separate logarithms added together. That's the same rule as if I'm multiplying x squared, x to the 4th, and I add the exponents. Kind of the same rule. It's a little bit backwards because here we're changing it to addition, but it looks like it's getting bigger, where the other one looks like it's getting smaller. It goes both directions. So if I start with the addition, I can combine that m and that n into one logarithm and make it a product. So that's product property. The next property that we used a lot in chapter 5 was x to the 5th divided by x to the 2nd. Sophie, what would I do in my chapter 5 exponential properties in this case? I would subtract the exponents. Oops, I put the answer by accident. Right, so when we are dividing, we actually subtract. So logarithms have the same property. Here, if I have a logarithm that is dividing two things, I can separate that division into separate logarithms. I can expand it into separate logarithms with subtraction. And it goes both ways. If I have subtraction, I can condense it to one logarithm dividing. And then the third major property that we had in chapter 5 was the power of a power. The power of a power. We had exponent on exponent. And Sierra, when I had exponent on exponent, what did I do? I multiplied them together. So the power property for logarithms say, on my logarithm, if I have an exponent, I'm going to take that exponent and I'm going to change it into multiplication. So I'm going to put it in front and I'm going to change it into multiplication. So the power becomes multiply. And it goes both ways. If there's multiply here, I can put it as an exponent. So I can move it back and forth if I want. They're equivalent. So today we're not necessarily doing anything super useful. Like solving equations. Today we're just gonna play around with this property and just get it in our head so we understand the properties, okay? So the stuff we're doing today isn't like what you would use for calculus or something like that. It's just getting the procedure set in our heads. And we're gonna do that by starting with just playing with properties. Use log base 2 of 3, and here's the answer. It's approximately 1.585. And use log base 2 of 7, which is approximately 2.807, and we're going to evaluate each logarithm. Tessa, do you know what the word evaluate means? So it doesn't necessarily mean simplify it, but you do need to simplify to evaluate. I'll give you guys a hint. Maybe somebody can help Tessa out, because I know if I called on any of you, a lot of times we don't understand the words we're using. Evaluate has the word value in it. Evaluate. You're finding what? I just highlighted the word. What? You're finding a value. Yes, you're finding a value, like you're finding a number. Evaluate means you're taking this all the way till you have one number. Sometimes with simplifying, we can't get to one number. But evaluate, we can get to one number. So we're going to use our properties. The first one is log base 2 of 3 divided by 7. We have a property that talks about division. What does it say to do for division? It says subtract. So what we're going to do, and we're going to write down the steps so that you have them all as notes. I'm going to rewrite this as log base 2 of 3 subtract log base 2 of 7. So when I change it into subtraction, both parts have that log. Now, in the directions, it tells me log base 2 of 3 is 1.585, and log base 2 of 7 is 2.807. So we could subtract those and find an answer. And you could do it without a calculator, but I don't want to waste a ton of time. I just want to get to the properties, not so much subtraction, because that is a, gosh, 4th grade math, 5th grade math, one of those two. Negative 1.222. That's what that one is. Okay, the next one is log base 2 of 21. Now, we have to use what's in our directions. We have to use either log base 2 of 3 or log base 2 of 7 to find log base 2 of 21. Or we could use both to find log base 2 of 21. Does anybody see how 21 has to do with either 3 or 7 or both? Jacob? 7 times 3 is 21. Right, so we're going to rewrite this. So this is log base 2 of 7 times 3. So we're going to rewrite this log as log base 2 of 7 plus log base 2 of 3. So just rewrite it. And then log base 2 of 7, I don't remember. Log base 2 of 7 is 2.807 plus 1.585, and I'll just find the answer for you. 4.392. See, we're just using the properties to learn how the properties work. In reality, if I told you to find log base 221, you would just use your calculator and type in log base 221. Okay, that's reality. This is just practicing properties so we understand how to use them. Okay, the next one is log base 249. We need to make 49 by either the 3 or the 7 or both. Jackson. We can use the 7 twice. So what operation would that be? Okay, I'm going to do it a different way if you don't mind. That way is fine. But I'm going to purposely do it this way instead. So he said log base 2 of 7 times 7. And we already did a times 1 right here. So I'm going to make it 7 squared instead. Both are the same. If I have log base 2 of 7 squared, I'm going to use my property that says take this power, move it to the front, and multiply it. So I'm going to have 2 times log base 2 of 7. So log base 2 of 7 is 2.807. So I'm going to multiply those. Multiply 2 times 2.807. It ends in a 14. Is it 5, 6, 14? No? Oh, yes? Oh, yay. Good. I make silly mistakes when I do it in my head, so I don't trust myself. If I write it down, I'm fine, but I make silly mistakes in my head. All right, the next one, log base 2 of 1/3. We're going to use either log base 2 of 3 or log base 2 of 7 or both to get 1/3. What? Sophie, how are we going to use it to make it 1/3 though? How do we change 3 into 1/3? Divide by what? How do we make the number 3 turn in to 1/3? A negative exponent. Perfect. So we're going to use log base 2 of 3 to the negative 1. So where does that negative 1 go? In front, it becomes multiplication. In front, so we have negative 1 multiplied by log base 2 of 3. And log base 2 of 3 was 1.585. So I have the answer. The next section says, well, it doesn't say it actually. It doesn't say it. But it says you try. So I'm going to stop talking for a moment. I want to see if you can figure any or all of these out. I will go over them and record it as well, but I want to give you some time to try to figure it out first. So for the first one, log base 6 of 5/8. We're going to do log base 6 of 5 minus log base 6 of 8. When you see division, we expand it with subtraction. And that'll give us, what are these numbers? 0.898 minus 1.161. If you are doing that by hand, because I saw some people doing it by hand, just really how it's supposed to be. I would subtract these numbers like their absolute values. I would subtract their absolute values. Yeah, I'm going to have to borrow. This is the only one I'm doing by hand. And then 5 minus 9, now I'm going to have to borrow. 15 minus 9 is 6. 0 minus 8, I'm going to have to borrow. 2, and then that's 0. Okay. That's what I would get. 0.263. Is that what you guys got using your calculator? Okay, just want to make sure that we've seen me doing it by hand at least once. It's a life skill, you know. Okay, the next one is log base 6 of 40, and I would think about that being log base 6 of 5 times 8. So I'm going to have log base 6 of 5 plus log base 6 of 8. Because when it's multiplication, I change it to addition and I expand the logarithms. So that'll give me 0.898 plus 1.161. Who got an answer for that? 2.259? Oh. 2.059? Okay, thank you. Those maths make it hard to hear. Okay, the next one, oops, I skipped one. Log base 6 of 64. I would think about that being log base 6 of 8 squared. I'm going to move that 2 in front. 2 times log base 6 of 8. So I get 2 times 1.61. Oops, 2. Wait, is it 2.322 or did I mess up? Okay, this is gonna make less ugly. Okay, 2.322. It's not gonna get less ugly. Okay. And then the last one, I would rewrite this as log base 6 of 5 to the third. I'm gonna take that 3, move it to the front. 3 times log base 6 of 5. So 3 times 0.898. And then who's got an answer for me? 614? No. Gosh, I can't hear you at all. 694. There you go. Yay. So those are logarithmic properties. Now we're going to use the logarithmic property to expand an expression. We're going to expand it. We're going to make it as long as we possibly can. Okay, so when we're expanding it, we are starting with the first part of the property. So expand goes from this side to this side of the property. Starts with the, with it being multiplied and separated to addition, or it starts with division and goes to subtraction, or it starts with an exponent and pulls it in front. That's expanding. So we're going to do that as much as we can for this example. So the first thing that I notice, and this is kind of like order of operations, but backwards, the first thing that I notice is that big fat division sign. So that's the first thing I'm going to take care of. I'm going to rewrite this as ln is log. So ln works for all these properties as well. ln 5x to the 7th minus ln y. So that's the first thing I'm going to do. Now, ln y, nothing else to do with that. It's expanded all the way. But ln 5x to the 7th, we can still do more stuff with. Is the 7th power on all of 5x? Ryan, is the 7th power on all of 5x? No, it's only on the x. So I'm going to do the separation of the multiplication first. So now I'm going to have ln 5 plus ln x to the 7th minus ln y. And then the last thing I need to do is take care of this exponent. So I'm going to do ln 5 plus 7 ln x minus ln y. So that would be expanded all the way. Now I want to show you something that is important, and there's not a whole lot of practice about it, so I kind of like to add things in here. If I rewrote this as, I don't know, ln 5 minus ln y plus 7 ln x, if I rewrote it as that, is it still equivalent? Do we have a rule in math that says we are allowed to add in a different order? Is there a rule in math that says we're allowed to add in a different order? Yes. The ln, because it has the minus sign in front of it, no matter where it's located, the lny, sorry, the y, is going to be on the bottom because of that subtraction sign. So it doesn't have to be listed last to be on the bottom. Anything that's positive will be on top, no matter what order it is. If it's listed as plus, it's going to be on top. I'm going to say that a few more times. All right, the next example is condensing a logarithm. So condensing would be the opposite of expanding. Condensing would be for all these properties. You're going to be given this side, condense, and you'll have to go backwards in the property. So condensing, you will end up with one logarithm when you're done. You will not have the word log written more than once. You will only write log once. Or ln. So you will only have the log or the ln written one time if you condense. If you have log 5 over log 8, you're wrong. Only one logarithm when you're done. So we're going to condense, and I'm going to look at each separate term, and the first thing I look for is going to be the exponents. Are there any terms that have a number in front that I could move to the exponent? So I'm going to have log 9 plus log 2 to the third minus log 3. The next thing I look for, adding, subtracting. Do we have any that are adding? Do we have some plus signs? Yes. Do we have any subtraction signs? What do we do if it's adding? What's property say to do if it's adding? Multiply. What's it say to do if it's subtraction? Divide. I'm going to do it in one step. I'm going to say 9 is positive, it's going to go on top. 2 to the third is positive, it's going to go on top. 3 is the negative, it's going to go on the bottom. So it becomes one fraction with anything that was positive on top, anything that's negative on the bottom. And since these are numbers, I can actually multiply and divide this out. That would be 3 times 8, 24. If there were x's, I could multiply it out all the way. Yes, dear.
Oh, so. Oh, that's my second.
Yeah? Okay. What else? I want to show you something else about this one before we go on. Can you make subtraction into addition? Is there some rule in math that allows us to make subtraction into addition? '11th graders. Is there a rule in math that allows you to make a subtraction sign into addition? What is it, Brooke? Adding a negative. Exactly. So I'm going to change something about this. When I changed that, I followed a math rule. I'm not making up math. I followed a math rule. So what I did was legal. When I changed that, this is actually a number in front of the log. What number is in front of that log? Close, it's not 1, -1, right? So you know how I used the 3 and moved it up to the top? I could use the -1. So I'm just going to do this example a different way. So how I moved that 3 in the middle term up to the top, I'm going to move the -1 to the exponent of the third term. Now they're all addition, so I'm just going to put them all on top. So I will have log of 9 times 2 to the third times 3 to the negative 1. What's 3 to the negative 1? Okay, so I have log of 9 times, I'm going to simplify that, 8 times 1/3. So I'm going to have log times 70. Sure, if you're going to go that way. I wasn't going to do it that way, but that's fine. 1/3. And then what's 72 times 1/3? Should be the same answer. Remember when you're multiplying, you can multiply in a different way, in a different order. So I actually would have done 9 times 1/3 first, because that's 3, and then multiplied by 8. But this works too. Okay. So you see they're the exact same answer. This one stayed all addition. This went straight to subtraction, but it doesn't matter which way you do it. Okay. All right. So we've got some you tries. We've got 4 of them that you're going to try. I'm going to pause the video and you're going to try it. And then I will record how we did it. Expanding. So I'm going to first separate right here where the 3 and the x to the 4th are multiplied. So I'm going to separate, since it is multiplication, I use addition. And then I also have to take care of this exponent. The exponent was not on the 3. That's why I didn't move it yet. I had to get rid of the 3 first. Now that it is only on the x to the 4th, I will move that 4 in front, multiply it. You notice that both of my logarithms have that same base of 6 on it. Both of the logarithms have the same base. The second one, so ln of 5, this is division. And division means we subtract. So I'm going to subtract ln 12x. This is what a lot of people did, but it was the next step that was wrong. So these, yes, these are multiplied together. However, the subtraction sign in front applies to both of them. If you look at the original, both 12 and x are in the bottom. So both 12 and x have to have minus. So ln 5 minus ln 12 minus ln x. So if you had that plus sign, I understand why you did it, because you're looking at only this term. But we also have to think in front there's a subtraction sign that applies to everything here. So both of them are subtraction. If you look at the beginning and you say, if it's on top, if it's on top, it's positive. If it's on the bottom, it's negative. Okay, the condensing, we're getting it down to 1 logarithm. This is subtraction. Subtraction means divide. So I write 1 logarithm and I divide x by 9. X divided by 9. That's it. Number 8, if it's positive, it's going to go on top. If it's negative, it'll go on the bottom, just thinking ahead of time. And also, if we have an exponent, we're going to move it up. So I'll have ln 4 plus ln 3 cubed minus ln 12. So I've got ln on top, I've got a 4 and a 3 cubed. On the bottom, I have a 12. So ln, I've got 4 times 27 divided by 12. I'm going to reduce the 4 with the 12. I'm going to reduce 3 with the 27, and I get ln 9 for my answer. Yes, Sophie?
On number 7, if you have log x over log y,
That would be wrong. Because when you condense, I'm going to go back up to where I wrote it down. When you condense, You can only have log or ln written once. So if you have log something over log something, it's wrong. Condensing condenses the stuff that is the log is of, the stuff after the word log. That's what it's condensing. It's not having more than one logarithm anymore. Okay, the very last section, I believe we've already done this. It's normally in this section, but I'm going to go over it one more time. Using a change of base. Using a change of base allows anybody with any calculator, as long as it has a log button on it, to find an answer. So where you might not have the button on your calculator that does this, and you just fill in the blanks, change of base allows you to use like a scientific calculator and do this. Change of base would be you use, with common logarithms, would be you use log 10, which is just log, and you do 8 over 3. So we do log 8 over log 3. That's going to give you the exact same answer that if you typed in your calculator log 3 of 8. This is called change of base. So with your calculator, I want you to type in this one. It's okay that you have the ability to type this in. I just want to see that you can also type it in the other way and make sure you still get the right answer. I have a calculator somewhere, so I'll do it up here. Somewhere. Where's my calculator? Here it is. Was it 8 over 3? Is that what it was? Is that what it was, guys? 8 over 3. Log 8. So I am going to close that parenthesis divided by log 3. Okay, and I'm going to show you that's the exact same answer as if you have the nice button, but not everybody does. So that's the exact same answer as just typing it in. So this is called change of base formula. And then the example 5 is how to change the base using natural logarithms. So here I've got log base 6 of 24. I can type into my calculator ln 24 over ln 6. You can type that into your calculator and it will give you the exact same answer as typing in, bless you, log base 6 of 24. ln 24 divided by ln 6. Okay, so you can see I got the exact same answer either way. You're just learning what change of base formula means. 1.774. And then the rest of it is just use the change of base. So you don't have to type it in. I just want you to quickly write down how you would type it in for each of these. You can either use log or you can use ln, your choice. How would you type it in to use change of base? I did both.